Let's try to dive into explanation of using a one-dimensional probability density function to represent the continuous random variable such as height. So how can we calculate the probability for a specific interval just by using the integration? Let's try to explain step by step. The first step is try to understanding the probability density function, which is denoted as f of x1 for height, which represents how the probability density of height measurement is distributed across different values. So it is not the probability itself, but it describes how densely the probability mass is distributed along various heights. Let's try to calculate the probability of this interval. So we try to find the probability that a male's height falls within a specific interval. Let's say it's between the 5.95 feet and 6.05 feet. So we integrate the PDF, which is possibility density function, over this interval. This integral calculates the total probability mass within this range, which effectively summing up the tiny bits of the probability across the infinitesimally small segments of this interval. Let's try to represent it mathematically. The probability that the height x1 lies between the 5.95 and 6.05 can be expressed mathematically as the probability that x1 is between 5.95 and 6.05 equals the integral from 5.95 to 6.05 of f of x1 with respect to x1. So this integral computes the area under the PDF, which is the possible density function curve from 5.95 to 6.05, which represent the probability of the height falling in that range. We just visualize a normal distribution, which represents the height. The sign shaded area represents the interval between 5.95 feet and 6.05 feet. And then we calculate the probability for this interval. We assume that heights are normally distributed with a mean of 6 feet and a standard deviation, which is 0.05 feet. So all of this depicts the probability density function for male heights. This curve shows how the probability density of the heights is distributed, and the peak at the mean indicates where the heights are most densely concentrated, and the sign area under the curve from 5.95 to 6.05 feet represents the probability that a randomly selected male's head will fall within this range. So this probability is calculated through the integral of the PDF probability density function over this interval. And the computed probability is a height falling between the 5.95 and 6.05 feet, which is approximately 0.6827, which is derived from the cumulative distribution function of the normal distribution and evaluated at the boundaries of the interval. This area under the curve from the 5.95 to 6.05 feet is calculated by integrating the PDF probability density function of that range. So this integration essentially sums up all the infinitesimal probabilities across that interval, which giving us a concentrated probability value. The value, which is 0.6827, indicates that there is about a 68.27% chance that the randomly chosen male from this population will have a height between 5.95 and 6.05 feet. This visualization and calculation effectively demonstrate how to use a PDF probability density function to find the probabilities over specific intervals for continuous random variables, which emphasizes the utility of integration in probabilities and statistics.